So the next conference is going to be led by a Mexican robotics team. They are located at Monterrey, and they are one of the most important teams around here. They have won 11 different regionals since 2018. Let's welcome Francisco, Gustavo, and Flora from Team 4635 Budbusters.
Hello, I'm Gustavo from 4635, and this is Aaron. He is a programmer from FRC, and I am one like a programming mentor now. And so we're just gonna give a little talk on what we use as electrical best practices. We're gonna have like a question section at the end and showing some pictures as well as our thought process during the entire process for wiring the robot to ensure that we have no electrical issues. Since in 2022, we had a really bad experience with our wiring. We had a lot of issues with the CAN and general wiring. So after that, we implemented a bunch of like setups that we use to ensure that we have no issues. And in 2023 and 2024, we didn't have any issues with wiring throughout the entire season and off season without redoing the wiring. So that was pretty good. Let me share the presentation. So these are some of the best practices that we use. Some of the most important points are order, structure, modularity, risk, and cleanliness. We focus on having these 5 points on the entire, like during the build season. It's also like a mentality when you wire it, when you're doing the work itself, having it be very clear, not just, oh, let's put this wire here and then this and this. It's an entire like process. He has wired a bunch of robots, and we have made mistakes with wiring in FTC last year. We had some issues as well, and we keep this mentality that helps us a lot with that. So specifically with order, trying to segment all of the cables, trying to make them easily accessible and easy to see where they go. Like if it's all mixed up and wired all together in like a jumble, like mess of cables, it's very difficult to see which wire goes where. If a motor fails, seeing if it's the encoder or the power or CAN, if you're using Neo's the encoder, and seeing where it's wired and that kind of stuff. That also affects how fast you can fix something. So order helps a lot with general wiring. I don't know if you want to add something onto that order.
Some of the practices we try to do, like always, is to have like segmented parts. For example, these two motors are connected. Well, not connected, but are they grouped? Also, these two, and just make sure that you're not like mixing cables or.
Yeah.
For example, this front motor goes with this back motor and then goes to the back of the robot. So just make like some crazy stuff. Just follow a line and make it flow.
We try to make sure that everything is mounted safely. A loose wire is a wire that can and most likely will get caught at some point in a mechanism. If it's just loose, there's a chance that it might get into the swerve or into the arm or whatever the case. So we do have like a way of structuring for loose wires that are used in movable mechanisms. But anything else that can be securely mounted to something, we mount it to something. With a lot of zip ties, as you can see here, we have like 6 zip ties for this. And you might say, like, if there is an issue with that cable, isn't it more of an issue changing it? And yes, but since it's all securely mounted, since it's all well wired, it's less likely to have any issues. And if issues do arise, you can wire it on top of it, like a new wire on top of it, and have that be like easier. Just wire it quickly to make sure that no issues arise from that. As you can see here, like everything is visible, and you can see that clearly this goes here, and all the wires are pretty clear to see. The next point would be like structure. Structure in the wires, not just everything is mounted securely, but whenever we have cables that are connected together, for example, the power cables are much stronger than CAN or encoder cables. So we make the CAN and encoder cables longer, so they have slack. And so if the entire cable chain is pulled, what will actually absorb the tension of that pull will be the power cables, not the sensitive cables. Here we have a harness. We try to make everything that comes out of a mechanism be the same thing. If you just have your elevator have like a bunch of wires, it's more things that could get tangled up, more things that could give you issues. So this was our 2023 robot. With this robot, we went to Monterey, Laguna, and Bayou Regional, and we won the 3 regionals. And we actually had an electrical issue with one of our swerves, and we were able to fix it due to the modularity. We're going to talk about that later. But we never had issues with this part of the robot, which is the cable part that would come out of the pivot, because that telescopic arm would pivot around this arc. And so by having all the cables tied together, you would have like it was actually very strong, even if we were using silicon cable with a lot of strands, and it was all like zip tied together. So it was pretty strong. Actually, the only cable that gave us issues is this Ethernet that we didn't end up using at the end of the season, but everything else got wired. Like, was pretty sound. This is a harness that we used for an FTC robot, and as you can see, like if all the cables are bundled together, they're generally stronger. So bundle them together, make them come out of like one place, so you can just keep an eye on that, not 5 different places. And actually, in the 2023 robot, the telescopic arm had this cable chain that would go inside the telescopic arm and into the end effector, and that had also more slack, and everything was tied together, and so it was very structurally sound. In 2023, in the Monterey Regional, our cable chain broke. Like, it just completely got destroyed, and we were able to use that same mechanism with just the cables without the cable chain, and it still worked fine. Like, not well, but fine enough, and we still won that regional. And going to the next one, modularity. Generally, all mechanisms are thought of as, if this breaks, what do we do, right? And so that's why we wire all of our cables in. You can disconnect them and take out the entire mechanism without having to rewire a lot of things. In Bayou, what happened is one of the encoders of one of the motors, I think it was the drive motor, just failed, and so we had to replace it. We thought, what's faster, replacing the entire module, because we already had a completely built module. So we said, let's just swap out the module, disconnect. We use power pole connectors for our power and CAN. I know some people use Wagos, and some people just solder them. I mean, it depends on who you ask. I know Citrus Circuits prefers to solder certain connections because of its less connector points. We use power poles, but whenever you take the cable and you remove, like you strip it, we crimp it, and then we add like a drop of solder to ensure that it's not gonna pull out. Because normally what happens is that it ends up like pulling out of the crimp. So we put a drop of solder to ensure that that doesn't happen. And so we wire it that way. And so we can just disconnect the entire mechanism and take out one of the modules, or for example, the telescopic arm, it was just a bunch of power poles, and you could take out the entire arm and put it back in. And the same for the end effector of the telescopic arm. This year, the wiring was a little bit more messy, but we still kept a bunch of modularity. I don't know if you want to add something onto that.
For example, on a regional, I think it was the Alabama regional, we had a problem with the motor of the intake. So what we did, instead of checking like what was happening, we just took out the module, like the motor, disconnect some power poles, and we took out the complete motor. We don't check like what was the exact issue, or if some part of the cable was crimped or something.
Yeah,
It's easier to just like swap the module or swap the motor completely, and also have prepared motors and modules so that you can in 1 or 2 minutes swap the whole system.
Yeah, so I'm taking a lot into in this year we used for in 2022 we used like the PWM connectors for CAN that you plug them together, and then you put like a little safety. We don't use those anymore because they gave us a lot of issues. I mean, you can make them work, but they're not that good. And we don't use them at all because we don't like them. They're not like safe enough. They end up pulling out of the crimp, or they end up just having like general issues, like getting broken at the crimp as well. So specifically with power poles, since we make them ourselves and we can ensure that they have that piece of solder, like that drop of solder and that shrink tube, we can ensure that it's better connected. As well with talking about batteries, your battery terminals, I think the name for the knots, it was like Nordlock. They sell them in Thrifty Bot. They're really good. They clamp on really well, and so we have that, and you can just have like good high quality cable, and we add shrink tube on top of the entire thing, like a very thick shrink tube that has glue, and so that locks everything together to ensure that it won't come loose or anything will happen to the battery terminal. This year we used SB50s, but we were planning on changing to SB120s for next year, and like 4-gauge wire, but that's just like personal preference, I guess. But yeah, modularity allows you to change your mechanisms quickly if anything breaks, and allows you to quickly like diagnose issues. So yeah, and everything has its own harness. So assessing like risks, you have to think, or what we do is we think like what could break. Always assume that what you think won't break will break, because that happens. I've had it happen with a lot of things during my. I've been, my rookie year was 2022. I started as a driver, and I was a driver for the team 2022 to 2024, and now I graduated, and he's now the driver, or one of the drivers. And how many times had I thought that something was not gonna break and it did? It's insane. So we assume that things are gonna get pulled, that things are gonna break, that things are gonna rip out. We've had like mechanisms break, and the only thing that's holding them together are like the cables or zip ties that we left. It has happened in this year in Monterey. We had the arc mechanism like just fail on us. It's the pivot for the shooter basically just failed, and so we lost that regional. because of that. And so we didn't assume that that was gonna break, and it did. So adding strain relief to all the cable connections. We also use silicon on the connectors, since even if they're like safe, like securely mounted, vibrations can make them like come loose. So just a little, like a drop of silicon, or these ones do have like a lot more silicon because we wanted to make sure that they never pulled out. And so this ensures that no vibrations will make them go loose. It'll help if it gets like grabbed onto something and pulled, it won't just rip out. And everything is like held together with zip ties and silicon, so it helps with like out of the case scenarios you might not be expecting. I don't know if you.
We also try to bring like all of these practices to FTC, since we've looked out that, for example, when I was a programmer lead and the electronic lead of 20 no of last year's FTC robot, we looked at we made some really big mistakes onto the electronics of the FTC robot. So what we tried to do this year, and when on going on to nationals, we asked for the FRC, like the mentors and all of that, to give us some good practice about what do we need to do or what could we do to ensure that we won't have these problems that we had on the Monterrey regional and Torreon regional onto the nationals. So to bring all of this practice of strain relief, of modularity, and all of these to also FTC teams, and you can also go to BEX. It's a really big change that could help you win a national or regional or any competition.
Yeah, having clean wires is very important, and that'll actually let us go to our next uh, point, which is cleanliness. Having clean wires allows you to think more clearly, to see if something is clearly out of the ordinary. Like if you have a clean cable, like cable sock, and then after a match you see that it's all like frayed and eaten up, that'll bring attention to you because it normally isn't like that. You are the ones that know the robot. Like you know the robot and you know how it's supposed to look like. So after a match, you just taking attention to see if something is out of the ordinary, because you know your robot's ordinary. Uh, that is something that you might want to like look into. So for example, here we have just two images of robots that we've wired and we thought that are kind of clean. As you can see, the cables are kind of hidden but still accessible. They are always thought about when the robot is being designed. If you just design the robot and like manufacture and then you slap on the electronics, things are not gonna fit. Like they're not designed, it's not taken into account into the design. So you'll have to like make things work, and that leads to more and more issues down the line. So we always take into account, what are we wiring, what do we want to have on a robot, what are we going to need. If we're going to wire X amount of cameras, we need an Orange Pi or a Raspberry Pi, or we're gonna have to power that as well. So we're gonna need something like a voltage regulator. And if we're gonna have a voltage regulator, where are we gonna feed that from? Like, are we gonna use the Rev power distribution module, or what are we gonna use to power it? So taking all of those factors into account, like what are we gonna use, and then actually putting it in the CAD allows us to, when you are actually wiring the robot, to things like generally go smoother, since you know where everything is going to go, and you can actually start thinking about how you're going to wire things before the robot is in front of you. And it can get really frustrating when like, oh, I have the robot in front of me, I just need to wired, like figure out how I'm gonna pass this or pass this cable or put this like. So if you already have an idea of how you're gonna wire things, you can wire them way more quickly and allow you to move way quicker during build season, which is very important. So yeah, like taking it into account in the CAD allows you to move faster and allows you to diagnose issues way faster. Because if you, as I stated before, like if you see something that's out of the ordinary, you can follow the trail or like do the proper debugging like things to fix it. Like take a look, be able to, if you have your PDH relatively accessible, you can check continuity between the motor and the PDH, and or check the CAN loop connectivity, or that it doesn't have a short or something like that kind of thing. Allows you to diagnose issues faster. If you're we had this year that we started using power poles, we had like a, it was literally just a cable with two power poles at the end. And we used that so that if we had any issues with the CAN, we could unplug, like for example, a surf module, plug that wire in, and we can figure out like, oh, wait, the issue is right here, like it's in this part of the wiring, because we can like take out pieces of the CAN from the robot's wiring, and that helped us during it never failed during a comp. We were practicing, and a cable had gotten, we had replaced the intake motor, and we didn't like clamp it like properly, like all the wires. So it got eaten up and was shorting the CAN, and we didn't know where. So we used that to figure out where it was, and then since we had changed that relatively recently, at that point in time, we said, oh, it might be this. And then we found the issue. And so instead of taking like an entire day or two, it took us like an hour. So we were quickly able to diagnose that issue, or even less. I think it was like 30 minutes. So that allows you to fix things way easier, because some electrical issues can be, they can like feel overwhelming. I mean, it kind of can get complex. So having clean things lets you think more clearly. And that would be like the end of our like best practices. We wanted to leave a little bit more space about questions, just to see if anyone had any questions. So if you guys have any. Please like leave them out in the chat.
So we are getting some questions. The first one is from an anonymous attendant. Where did you guys buy the power pole connectors or WAGO connectors? We are from Mexico too. Is there any reliable supplier?
Yes, we buy them from DigiKey or Mouser. They're both like pretty reliable sources to buy the Wago connectors. And I'm not sure about the Wagos, but the power poles. I know power poles are available in DigiKey. The what was it? Like I don't remember if it's PP45 or PS45, but the 12 gauge and the 22 gauge sizes are both available in DigiKey, and the connector, like the housing, both green and yellow, are available in DigiKey, as well as the red, black, and white.
Okay, thank you for your answer. This is a second question from an anonymous attendant also. Is there a place to learn about wiring in FRC specific?
I think if you look into the FRC documentation, like if you just look for the first docs, there is a specific like page for wiring as well. Like every what do you call them? Like Rev and CTRE have their documentation on their specific like products. So if you're thinking like how, or Limelight, for example, I don't know how to wire the Limelight, you can go into the Limelight docs, and they have like a page about wiring. And if you're talking about specifically like best practices or that kind of stuff, it's also kind of experience. We've had a lot of electrical issues during the years, and we always learn upon them. Like if something fails, we are happy about it. We are glad that it failed. If it failed outside of comp, that is amazing. Thank God. And we try to fix it without rushing. Like what do you prefer? Having to fix it during comp or taking an extra 2 or 3 hours to make sure that it's wired properly? Like if a cable is a little bit chewed up and you're in your shop, just change the cable. Like just it's better than having it cause issues later that might take you even more time. So might as well change it when you have time and that kind of stuff. It's experienced among the years, and so like this is just like a little collection of that.
Perfect. Okay, moving on to our next question. Revan Van Hoy from Team 2996 asks, when during build season, do you guys work on wiring? Do you set aside any time for wiring? Do you work alongside other sub-teams or take turns?
It depends. So it has like changed on the like during the years. We normally have like a specific time that we wire things. Sometimes they just, oh, here's the chassis. We're still manufacturing the mechanisms, so wire this. And so we have like a day to wire it, and so we wire the chassis, and then we're like, oh, we're done. Oh, and they start mounting the mechanisms, and we just do some prep work for when the mechanisms are actually wired on. The wiring guys also check the CAD to make sure that where they're passing a cable, like you can actually do it, because we've had it happened to me that like I wired an entire swerve module and I figured it should be fine. It wasn't fine. There was a frame where I passed the cables, so they had to like we had to unwire it, put the frame, and then wire it again. It's something that happens since we do work in tandem sometimes. In 2022 specifically, they were like, okay, here's practically the entire robot done. Wire it. And so we took like 2 or 3 days, and like from no wires to wires. Last year it was kind of the same. Like since we manufacture everything pretty quickly, it's just like, okay, we're building everything, and so in 3 days we have the entire robot built. Now we have 3 days of just wiring. It depends on the season, but if we do take turns, we make sure that we won't interfere with each other's work.
Okay, thank you for that great answer. From an anonymous attendant, how do you solve your electronic problem while in competition?
It depends on the problem. If it's low voltage, like generally what happens is power won't give you issues unless it's like a broken cable or it's touching like like for example your breaker popping. That might be like a high current issue that might happen. For that one, we just check which motor is like, or what mechanisms are consuming like way too much current. We generally fix that like like in the shop, but we haven't had any real issues with our breakers popping. Specifically with like broken cables or that kind of stuff, we also take that into account when we're wiring. Like if like you don't want a cable to do a 90-degree bend or be like forcing itself again and again and again and again, because you know it's gonna end up breaking. Like metal fatigue does happen. We've had cables like almost be completely chewed up. But since we like, you kind of get like a point where you kind of estimate what's gonna happen. Like you think, I don't know if you have like an example.
You can go for like steps of debugging. First, what mechanism isn't working, or what do you expect to do on that mechanism?
Yeah.
And like first, like watch physically all the wires that are going to that mechanism. For example, on our off season here in Mexico, we had an issue with the limelight, and we like
I don't know if you can see it.
A cable that was ripped.
It got chewed up.
And part of this problem was that this part of the robot wasn't planned well. So this was added after we finished all the CAD and all that stuff. So this is part of why we told you like to
think about it before wiring it, like not just wire it. But generally, if something is failing, uh, electrical issues mostly come from cables breaking, having high resistance, having them get like chewed up inside.
Not connected.
If they're not properly seated, if the connectors are not properly seated, if yeah, like that kind of stuff. So, for example, if one of your sparks or I'm talking specifically about sparks since they don't have like uh connectors that are like screwed on, like the Krakens or the Vortex that are like soldered on. Like unplug it, plug it back in, that kind of stuff. We try that first. If that fixes the issue, great. If it doesn't, where else could the issue be? Like if it's a CAN issue and it's just one motor controller, it's most likely that it's just that motor controller's wiring, not the entire robot's. If it's the entire robot dying, then your CAN might have like a short or it might be broken somewhere. So we unplug from the RoboRio and the PDH, and we check continuity between green and yellow, and check continuity between green and yellow. And if that's giving you like a short, then there's your issue. You just have to figure out like in what part of the CAN specifically, and that's where we use our modularity, which we unplug the connectors, plug the like fake cable, and so we basically take pieces of the robot's wiring out virtually with the cable to ensure that, oh wait, here we do have continuity, so that means that in these connectors and to where they go, there's an issue. If it's an Ethernet cable, it most likely is that it's chewed up or badly connected. Uh, Generally, those issues are like come from the wires themselves, not everything else. So we check continuity and that after we fix it, test it. If it works, great. If not, keep working and keep looking as fast as you can.
Yeah. Well, that's how it works at the regionals, right?
Yeah. Try to
Okay,
do it
so
as fast as you can.
yeah, definitely. So we have two questions that are technically the same. Could you share your slide and can it be used as a source for our rookie workshops? And that the other question is, can we have the presentation slides? It's kind of like the same question. So
Uh, yeah, we shared it to Robotics. You guys should have them. I think we sent them to your email in both English and Spanish. And if you guys want to use them, you're free to use them.
okay. We have just a few more questions if you're okay with it.
Oh
Yeah.
yeah.
Okay,
Yeah.
perfect. So we have one that says, how do you plan your robot's wiring, placement of the different parts, and etc. while making the robot?
We have like a main idea of how we want to wire a robot. For example, last year, what we used to do was all of our components on top of the belly pan. What we could and what didn't fit there, we would make fit on other parts of the robot. In 2023, since we made a chassis that was 23 by 23 inches, it was pretty small. The PDH didn't fit on the on the belly pan, so we moved it to one of the triangles that supported the arc that held together the pivot for the arm mechanism. That so we just placed it there. You have to think like what am I gonna use and what needs to be close together. Like if you're gonna have a camera and you can like it's an option for you to have the orange pie be like close by, try to make it be close by. If that orange pie is gonna need a voltage regulator module and it can be close by, have it also like kind of be close by. It's kind of like a what am I gonna need and how can I make life easier for myself? Because if it breaks, you're the one who's gonna be fixing it. If there are issues, you're the one that's gonna be like fixing those issues, and you're the one who's gonna wire it, right? Or well, your team. So make life easier for everyone and see how things can like maybe like some compromises or is there any chance that these frames could have like a slot cut out so we could pass wires through there? Oh yes, okay. dope. And so we can take that into account. Then the CAD guys do that. So for example, for our wiring this year, we're gonna do like underbelly fan, that kind of stuff. And so we start with that idea, and so they start placing the parts. Like some parts are just generally like we try to have them on the Pelipan, like the Roborio or the PDH or now the PDP2. That kind of stuff. It's just trying to have everything close by and seeing where it fits, where it would be easy. Is there enough space for me to wire this? Like, is that like a possibility? I'm not sure. Maybe check it in real life. Like take a PDH and put a cable in and see how much space can you still put a cable in there and check if you want to have easy like being able to check continuity, leaving the PDH uncovered, so you could put the probe in, like the multimeter probe, like put it in, that kind of stuff. So you just run that like it like you end up. And I mean, a lot of this is also experience, so try to wire as many robots as you can. And if you wired something and you think, I'm not 100% sure about it, take it off and do it again. It's fine. Like if you have the time, do it. You rather have like rewire it than having to fix it during comp. Always. So we always do that. I've redone electrical work various times. Like I've wired something and I just didn't like it. Like yeah, everything moved and it worked, but I didn't feel like it was like good enough or that there could still be something that got snagged, so I rewired everything through a different place or that kind of stuff. It's just kind of seeing what could break and learning from experience.
Okay, well, thank you very much for this answer. We have another one from an anonymous attendee. What recommendation would you give to new equipment?
Which like where to buy it from or
to a new team.
Well, it is to new equipment, maybe.
well, checking like what you're gonna use. So we used to have the Navex until it gave us issues, so we decided to buy the Pigeon, and we've been using Pigeon 2. We saw that the candies were coming out and the can ranges, so we decided to purchase those. The P2 as well, because it gives you like what 24 channels, if I remember correctly. It was like one of those things that I don't know. Well, generally, it's what do you think you're gonna use? If you go into the first docs, you can see like what other teams are using. We've seen what Mechanical Advantage is doing and said, oh, I want that. Like specifically the cameras they use, we just took those, and that kind of stuff.
Okay. Well, thank you. There is another question here from an anonymous attendee also. On average, how many times you guys iterate the wiring design to get to the best one?
We like first make a rough sketch about what do we want for wiring or what do the mechanisms will require. But on average, it would be like 3-4 times probably. We also like try to test some things on off season. For example,
Yeah.
If we have like new people in the team, we want them to put like hands-on to wire
Hands-on
up,
experience is
to go to a competition. If
really
there's a
good.
problem, to fix that problem by themselves.
Yeah.
Not just give them like, oh, you need to do this, this, and this. Like figure out what could you do.
Giving them opportunities to grow. Yeah, that like hands-on experience is really good. So like as you get more and more experience, you might need to iterate less. There are things that are harder to wire than others. We also think about how we're gonna wire things before we wire them a lot. Like specifically like the 2023 telescopic. That was okay. So how we're gonna actually wire this thing? And so we wired it fine the first time because we had thought about it a long time before. Like we thought like how are we actually gonna wire this thing? And after wire like and we had to do like the cable structure thingy. That we did do like 5 times because we liked it a certain way, but we saw that it kind of got like a little bit hooked on one side, so we kind of changed the cut like the length of some cables to push it to one side or the other. It depends on the mechanism. Some you can get them on the first try and you're comfortable with them, and some you might have to redo them like 4 or 5 times. It depends.
Okay. Well, we are actually running a little bit out of time, so you're super welcome to stay here, and if you can answer some of them, like written answers, would be so, so amazing. Do you have any final thoughts about your presentation that you want to wrap it up?
To generally, don't be lazy with your wiring. Think about it of how you're gonna wire it, and always if you can fix it in the shop, it's always better than fix it in comp. Taking your time in the shop is much, much better than having to fix it in 15 or 10, 15 minutes at comp. So yeah, I would say that and help yourself. So if it does happen, you can fix it in those 10, 15 minutes at comp.
Definitely. That's such a great advice. Thank you very much for sharing your knowledge, being part of this warm-up event. Your tips are going to help a lot of teams, I can assure you. So thank you. Thank you very much for being part. And of course, you're welcome to stay. And if you want to answer some of those questions, that would be really great. But thank you
Thank
again.
you. Thank you very much for the invitation. We loved it. We love sharing and contributing to the community.